Where I see people genuinely lose a lot of time, even when they think they're saving time, is the following circumstance. You need to create a React website. You're going to use Vite or Webpack. You say to yourself, I cannot remember off the top of my head how to set up my Webpack config or my Vite config. There's so much that's going on in those. So you know what I'll use? I'll use a cookie cutter library. Or I'll go into my notebook and I'll look up the last time I did it, or I'll go into my shell history, or I'll go into my notes.txt and I'll copy and paste from that. We recently did motion studies with a bunch of participants, many of whom were full-time programmers with a scientific bent. And we discovered in those motion studies that for some tasks, system administration related, they had notes.txt files where they had taken all of their notes of all of the commands that they had used, complex git commands and complex shell commands. And they'd go to that notes file and say, oh, wait, where's the file for setting up a git remote with git work tree and all of these other details? And they would lose so much time going through their notes trying to find the relevant thing and then adapt it. It is, I think, an important principle as part of all of this to build up repeatable muscle memory around common actions. This is why I am able to do things like write certain very precise things like creating random entities from a NumPy ND array contiguously using ASCII lowercase as the entities that you're going to select from, because I've done it over and over and over, and I've explicitly and purposefully done it over and over and over to build up the muscle memory. Because if it's the case that I had turned this into some library, and I had said, oh, you know what, this can just be a, helper, create entities like this, and I just imported that library every time, yeah, I'll save myself time. I'll save myself the time that it takes to write all of these lines of code. However, the moment this thing breaks, or the moment this thing needs another modality, for example, maybe the entities need to have digits in them, whatever the case may be, I have to either rewrite this thing from scratch, which I will have no idea how to do because I haven't touched this thing in forever. It's a risk of automation. The easier it is, the less likely you are to revisit how it actually works, and the more reliant you are on it working perfectly. So the moment it doesn't work perfectly, everything falls apart. And remember, whenever you have automation, where this constitutes a form of automation as well, simple helper libraries are a form of automation. What's going to happen is you're going to build margins around the work that you do based off of the time and the efficiency that you gain. So you're going to say, I'm so much more efficient with all of this tooling. Therefore, I'm going to commit myself to doing more work. Then the tooling breaks, and then suddenly you have to do things the slow way, and you've committed to doing work that you simply cannot service without the automation. You are reliant on the automation, but you are helpless in the case where it breaks in very small ways. This is why whenever you build this kind of tooling, this automation, it is absolutely critical for you to, in parallel, build the ability to reconstitute that automation from scratch or to decompose that automation into smaller parts. The muscle memory, I think, is a very important thing, and I am very guilty of it because you should see how often I don't want to write out my iNotify trigger line. I Control R, and then I add layers and layers and layers on top of this that become more and more fragile. What I really should do is every time I should rewrite this thing from scratch, so I always remember how to constitute one of these things without having to rely on my history being in a certain state. Or what I should do is I should change my automation to make it easier for me to reconstitute from scratch. So for example, if there are common things that I'm always checking, maybe I should change the name of this thing to be shorter. Maybe I should add a flag that doesn't require that I know exactly the file. Maybe I should even change my use. Maybe I should just trigger on any files that change in my home directory. That's easier for me to remember. I have all of these choices for how to decompose this, but fundamentally, being able to write those things from scratch is important. This is why when we have done examples in JavaScript for you, I've often written the Vite config.js from scratch. I am a big believer that things like cookie cutters will help you speed up your work, while also making you completely unable to live without it. Once you become reliant on that and once you have organized your work around the assumption that cookie cutter is there, the moment it's not available to you, you're stuck. And you're stuck having already committed yourself to additional work. This is why the only times where we won't write something from scratch is simply because if we write it from scratch, the amount of time it would take would preclude us from talking about important things in that session. Otherwise, every single time I show you a JavaScript example, I would always write that Vite config from scratch. And one of the reasons why I would convince you that maybe Vite is a good tool on top of Webpack is not just because it's fast, but because I can minimally configure it from memory every single time. All of these principles together combine to give us a good working experience. It is the case that these principles overlap slightly. It's not the case that decomposition is completely independent from isolation, which is completely independent from the idea of our reduction of context switching, was completely independent of our idea of muscle memory. But it's the case that all of these come together in order to give us a good iteration loop. At its core, what I want you to focus on is it doesn't matter about the tools. Whatever tools you have are tools which you want to design so that, if they break, you can still live without them. Or if they break, you can rewrite them from scratch, or you can do the original action efficiently from scratch in the absence of them. And all of those tools should be designed under certain principles. Eliminate the outside world, the dependencies of the outside world. Eliminate focusing on things that you don't care about right then and there. Eliminate aspects of the problem that you're not worried about by decomposing the problem into individual parts. Eliminate context switching so that you're always focused on that action. And make sure that you can write even the simplest of those actions from memory so you can get a very tight iteration loop. An iteration loop ideally at the speed of or faster than the speed of your action. Without showing you more examples of this, it's hard for you to really internalize this, and I would really suggest that you don't rush off and change your process. Instead, here's what I want you to do. Find a very small task. Maybe it's a LeetCode problem. Maybe it's a problem that you see on Stack Overflow that you want to try for yourself. Jump onto a Zoom call with just yourself. Turn on the recording. Record yourself working, and then watch that recording after the fact. Think about which parts of your process were actually solving the problem and which parts were you saying, oh no, I don't have the right Python installed. Maybe I need to have virtual environments ready to go. Maybe I need to isolate myself more effectively. Look at where things seem to be slower and not just 2 minutes taken looking something up. Oh, maybe I need to know the pandas methods a little bit better. But even cases where small incremental actions that should be 1 second are actually 2 or 3 or 4 seconds. See what differentiates your work from the work of your colleagues or from the work that we do in our live coding. Because I have told you many times, the live coding that we do is ultimately a gimmick. The gimmick of it is being able to speak and code at the same time. The gimmick of it is being able to type very quickly. This is a practiced activity. But the core of what the live coding actually shows you, that is, effective iteration, is not a gimmick. Oftentimes, we are on the spot to write some very complex code from you right then and there with minimal preparation, and the ways in which we structure that code follows all of these principles. This is how Cameron is able to do sophisticated matplotlib demonstrations for you from scratch, off the top of his head, having minimal preparation time, because he knows how to isolate his work and he's not fumbling around with one tiny little detail here, or wasting time moving between two windows, or wasting time trying to find where did that plot pop up on my desktop. He has everything set up to do something and immediately see the results. And oftentimes you'll see that when he works or when I work, we'll write some code. We'll say, oh, that's good. The output will actually be wrong because in between writing that line of code and seeing the output, we already spotted something that we did wrong. We'll make a tiny change and then it'll be right. And the time between when we decided to do something and we had working code is very short. 2 quick iteration loops of 2 seconds, where that iteration in the middle was just spot checking that we got all the spelling right. With all of that said, I want to thank all of you for joining this session. This session is part of a training based on performance. In our previous session, we talked about Python performance. In this session, we talked about your own human performance. In our next session, we're going to be talking about performance from the typical approach, we're going to be talking about how you measure performance in the performance of code. We'll be talking about debugging approaches. We'll be talking about measurement approaches. We'll be talking about some of the new very exciting profilers that you have, memory profilers like Memray, and computation time profilers like Scalene. In the final session of this series, we'll be talking about specific problems related to Pandas performance. How do I know if my Pandas code is going to be slow without even measuring it? Because I know certain things about Pandas. We will also be doing a bonus session for those of you who are paid attendees. It is not too late to get a ticket for this session and to join us for that. I think we might even consider, depending on your feedback, whether or not we want to use that bonus session as an opportunity to do some micro motion studies with all of you so that we can see how all of these different aspects of performance, the performance of your Python code, the performance of your Pandas code, your ability to measure the performance of your code, and your own personal iteration loop and performance of writing code come together to produce the best possible working output. With all of that said, I want to thank you all for joining, and I'll see you all next time.